This chapter deals with specifications and the notes that would be applied to the drawing, and there are standards that you should follow in placing those so that the people in the machine shop or the manufacturing floor will understand what you're trying to tell them because you're going to follow the standards. A couple of, I guess, important things is to understand the difference between a general note and a local note. Okay, so general means it applies to the entire drawing, like a fillets and rounds note of being a certain radius, or a chamfer note that all chamfers are whatever, or maybe a note to tumble part to remove burrs, or something similar to those things. That would apply to the entire part, whereas a local note applies to a very specific portion of the part, and you'll see that in here. Another important thing to be aware of is that this chapter talks about the old way of noting drawings and the new standard that should be followed. You will see in a lot of the drawings from the technical drawing with engineering graphics textbook, those things are noted with the old method of doing things, like neck sizes, keyway sizes, knurls and broaches, and lots of those kinds of things. For two reasons. One reason, those drawings were created under the old standards, and secondly, it's very difficult to dimension an isometric drawing. So they use a local note with a leader to give you the size of a neck, an undercut, a keyway, a key slot, things like that. But when you start doing drawings and dimensioning them, follow the new standard for what you're dimensioning. Okay, so let's see, symbols. Here's a bunch of typical symbols that you're going to see on drawings. There are more than this, of course, but those are the ones that you would use most often, okay? Okay. Counter bores, spot faces, countersinks, different examples here, okay, what you're looking at. Come on. Countersinks, drilled holes. I can't emphasize this enough. People in several classes continually make this mistake. The depth of a drilled hole is to the flat of the cone, not to the tip of the cone, okay? That's just the way it is, because this cone drawing represents the end of the drill bit that drilled the hole. Okay, so you need to remember that. Come on, there we go. Okay, chamfers. Chamfers either need a size and an angle, or they need two sizes, one or the other, okay? Okay, so here, this is what we mean by a neck or an undercut. This was the old way of noting it, and you'll see this in the technical drawing book a lot. This is the way it should be dimensioned now. Okay, and it works the same way with a keyway. Okay, here's an example of an undercut. It should be dimensioned in linearly. Keyways in the same fashion here. In your textbook, you'll see a leader with the size given. This is how it should be dimensioned in drawings. Okay. Broaching, knurls. Come on, my pages are changing here. Okay. So questions? Pretty self-explanatory on that. All right, these two activities, review activity 11.1 and 11.2, you will need to print out these pages because you're actually going to write in the information and the symbols. So for number 2, a 0.375 diameter hole, 0.5 deep, with a 0.625 diameter countersink with an included angle of 90 degrees. So you would write that note with the symbols and the dimensions up here in proper format. You can look back through the textbook for examples, not a problem. But you're going to, write that in. And please write neatly, because if I can't, fully read it and understand it, then how can I grade it? But you'll need to print this out and draw that, and then either scan it or photograph it and turn it into the Dropbox in Blackboard. And the same way with activity 2 here, it's giving you the symbol. You have to write out what the symbol means, okay? And use the previous activity as examples of how they should be worded. All right. And let's see, we're doing this one, industry print here, so looks good. Okay, if you got questions, send me an email or come see me, okay?